So today we're going to continue our adventure with matrices. We are going to multiply matrices. Now, we did scalar multiplication the last 2 days, but we are actually going to multiply two matrices together today and tomorrow. Okay? It is a procedure, and you have to follow it. And if you don't follow it, you will get the wrong answer. Most things. So first thing you need to know that the order makes a difference. So AB is different from BA. AB means multiply A times B, doesn't it?
Yes.
And that just tells you right there, matrix multiplication is not commutative. If you happen to get AB equal to BA, which it does happen, those matrices are known as inverse matrices. But in general, matrix multiplication is not commutative. So you can't change the order because you want to make it look prettier or whatever. The next thing, in order for it to work, the columns of the first matrix must equal the rows of the second matrix. In other words, the inner two dimensions must equal. So if I have 7 by 5, the next one has to start with a what? 5. It doesn't matter what it ends with, but it has to start with a 5. These two have to equal for this to work. If they don't equal, 7 by 5 times a 6 by 5, and you will write this on your paper when you're deciding this. You circle the two, and are they equal?
No.
Nope. So it is undefined. Okay, it's undefined mismatched dimensions, but since you wrote the dimensions, circled it, and said not equal, you don't have to write all the other. Okay? If you want to write undefined mismatched dimensions, then I guess you go for it. But I like to just write them and circle it, say not equal, and say undefined. Doesn't work. Okay? So if it does work, what's really fun is the result, the product, the answer will be the outer two dimensions. So an 8 by 1 and a 1 by 8 will result in a is equal. Nope.
8.
An 8 by 8.
Oh, okay.
Okay. It will result in an 8 by 8 matrix. 8 rows, 8 columns.
I hope all of our homework is 8 by 8.
Okay, so for example, you have my number 2.
Mm-hmm.
So it'd be 7 by whatever other number.
Right. So this 7 by 9,
Okay.
that would result in a.
Okay. All right.
Okay.
I got this.
So down here we have a 2 by 1 and a 1 by 2.
Yes.
So the middle are 1 and 1. So my result is going to be a
2 by 2.
2 by 2. I wrote 2 different 2's. Okay. Then I have a 1 by 2 and a 2 by 1.
So 1 by 1.
So it's going to be a 1 by 1. Now you notice these are the same matrices, yes?
Yes.
Okay. Now, could it possibly be even the right answer if one is the same answer if one's a 2 by 2 and one's a 1 by 1? No. They can't even. There's no way. Right there, it shows you matrix multiplication is not commutative. Because if it's commutative, then every single time it's commutative, right?
Yes.
So the only time again is when you multiply by identities, and we'll do that next week. We're going to find the identity matrices and things like that. Okay, so are we good?
Yes, and just like 2.4 more seconds.
Wait, so that's how we know we find the answer.
0.4. Bam, done.
Well,
Okay,
you
yeah,
don't.
I'm done.
This right here, okay, right here just told me does it work and what am I going to get? I haven't told you anything about how to do it yet. Okay? So this slide, I want to know, is it possible and what will I get once I know the procedure? Okay? So this is a what by what?
3 by 2.
A 3 by 2
No.
and a
It's
3
impossible.
by 2.
It's undefined.
And so I would circle it, say
Line.
not equal.
No.
Undefined.
You may not multiply
just have to put undefined, you don't have to put anything, right?
No, as long as you show me the dimensions. If you don't show the dimensions, you have to say undefined mismatched dimensions.
Okay.
Okay, so what do I have here?
2 by
2 by
3.
2 by 3
3 by 2.
and a 3 by 2.
Is
So
a 2
these
by
are
2.
equal. So it will be a
2 by 2.
2 by 2. And guys, that's really helpful when you are multiplying these to make sure you have the right answer when you're done. Because if I don't have a 2 by 2 when I'm done, did I do something wrong?
Yes.
Yes. So take the few seconds that it takes to do that and do it.
Okay.
Okay, what do I have here?
3 by 2.
3 by 2
2 by 3.
and a 2 by 3. So it works, and I'm going to have a
3 by
3 by 3. Then I have a
3
by
by
1.
3 by 1,
1 by
1 by
3.
3.
1 by 3,
You do that to
3 by 3.
and so I get a 3 by 3.
The 2 by 2 and 2 by 2. It's going to be a 2 by 2.
Oh, I thought I had the other. Oh, they're the same.
Everything's the same.
It's a 3 by 3.
Still for no reason.
And a 2 by 2.
So it's
No,
undefined.
undefined.
It's really sloppy. Now, it's almost as important, actually, to me, it's more important to know when it doesn't work than when it does. Because if I know it doesn't work, I save myself a lot of trouble. Yes. And once it doesn't work, you're like, yes, it doesn't work, I don't have to do the problem. I can tell you there are probably none that are, I don't think there are any that are undefined in your homework. Sorry.
Yes.
So that means you have to do them all. And you do have to show me minimal work, and I will explain to you what it is. Okay, so matrix multiplication is a
No.
row column operation. Okay? It is a row column operation. You take the rows of the first and you multiply it times the columns of the second. So, first row, first column. Yes?
Yes. Yep.
So A is in the first position, first row, first column. Well, first row, first column gives me the first term in the, okay, that result. So A times W plus B times W.
That's why.
Why? Sorry. First thing times first thing, second times second thing, third thing times third thing, and so on. Now do you see why the columns and the rows have to equal up?
Yes.
Yes. Okay. So then I take, once I finish this and get this term, and you guys had terms that look like that yesterday, right, in your worksheet?
Yeah.
You didn't know the variables. Then I go the first row with the, guess
Second
what?
column.
Second column. So that gives me A sub first row, second column. Look at that. First thing times first thing. So A times X. Second thing times second thing. So B times E. So I keep going until all my columns are done.
Yes.
So did I exhaust all my columns
Yes.
here? So now I move to the
Second.
second row.
Second row, first column.
I do the second row, the first column. First thing times first thing, plus second thing times second thing. And then
Second row.
second row, second column. First thing times first thing, plus second thing times second thing. And if there was a third thing, you take the third thing, and fourth thing, and fifth thing. You go until you're done. So that is why the columns of the first have to match the rows of the second. If you don't have things to pair up, then you've done something wrong. Sometimes it's people are going row to row instead of row to column. Sometimes they should have known at the beginning that it wouldn't work. Everyone got this? Lena, you good?
Yeah.
Okay, so we're going to do this. First one is a what? What's the dimensions?
2 by 3.
A 2 by 3. Do I need to switch from green?
No.
Okay. And then I
3 by
have a
2,
3 by 2. So I'm gonna get what when I'm done?
a 2 by 2.
A 2 by 2. And that's what they have, and that's, we're not gonna put it in there, we're not gonna mess with it. We're gonna put it just next to it. Okay, so when I do this, this first row, first column is going to be one term, isn't it? It's gonna be the A's of 1 and 1. So, first thing, so 1 times 0 plus second thing times second thing, 2 times 1 plus
4 times 5.
4 times 5. That's all one term. It's the sum of the products of the column and the row.
What's the last one? That's what? 4 and 5.
5, 4, 5. I didn't give you time to write down that matrix. I'm sorry. I'll let you catch up. He's gonna tell me. I just kind of
Okay, slow down.
slow down. I just kind of went. Is everyone caught up? Okay. So now I need to do the first row with the what column?
Second column.
Second column. So I leave a gap because it's another term, right? So 1 times what?
1
1
plus
plus
2 times 4
2
plus
times 4
4 times 8.
plus 4 times 8. I would keep going if I had more columns. And keep putting terms in that first row. So now I need to go to the second row, what?
First column.
First column.
3 times
3 times
0
0
plus 9 times 1
plus 9 times 1.
plus 9 times 5.
Everybody following where I'm getting numbers?
Yes. I've got it.
Guess when you do the last one when you're on?
Yes, I've got it.
Yes.
Got the magic.
Okay, so did you get 3 times 1, 9
Yes.
times 4, 9 times 8?
Yes, Evan got it.
Now, before I go any further, I want us to stop and look at this. Do you see any patterns?
Yes. All your parentheses go down.
Which are your columns, right? Your parentheses are your columns. Are your columns your columns?
Yeah. Are the columns the columns?
Like 0, 0,
Oh, yeah.
1, 1,
The
5,
columns
5,
are
1,
vertical,
1,
just
4,
like
4.
the columns are vertical.
Okay. Are your columns your columns?
Yes.
Do they match up?
Yes.
Okay. Are your rows your rows?
Yes,
1,
yes.
2, 4, 1, 2, 4, 3, 9, 9, 3, 9, 9.
Yes.
Okay, I'm going to tell you, you're going to try to not do this. You're going to try to just write the answers and blah, blah, blah. Doing this today would tremendously help you later on. They're going to get more complex. If you do them with everything when they're not, when they get more complex, is it easier to kind of skip a step to make it easier? Yes. So, now I have to do the math. Right here is the minimal work. I think it froze up on me.
Open up your computer.
No, it didn't. Okay, so, no, I didn't shut it that far. So equals, right here is the minimal work from here on that I will accept. 1 times 0 is 0 plus 2 plus
20.
20. Equals what?
22.
22. Okay, and then I get
1
1
plus 8
8
plus
plus
32.
32.
That's
41.
Okay, and then
0 plus 9 plus 45.
that's a plus
Is it?
And that
So-
is
54.
54. And then 3 plus 36 plus 72.
111.
Okay, so right here is the minimal work I will take.
Okay. That is what you will get from.
I know, that's why I had to be specific. The other will help you, but that's on you. I just keep going through it. You have one in your assignment that is a 1x3 and a 3x2. So what's my answer?
A 1x2.
A 1x2. So that's going to be one row with two elements in it, right?
Mhm.
So we'll probably have some long things to do. But most of them are 2x2s, but not all of them. You're going to have some questions, and we're not going to answer them all like by completely working them out here, but you will have to on your assignment. I've already told you that in general, A times B is not equal to B times A, haven't I?
Yes.
Okay, but it can happen. Can happen. So we'll do this one since it's basic. I have a 2x2 and a 2x2. Does it work? I'm going to end up with what?
A 2x2.
2x2s. And these are pretty easy because it's a 2x2, 2x2, 2x2.
That's B.
You know. So we're going to go and I'm going to do A, B. And you want to write the whole thing out or just the result?
Just the result.
Just everyone okay with that?
Yes.
Okay. So -2 times -1 is 2. And then I have to do 1 times 0. So that's +0. Then is that row exhausted with the first column?
Yes.
Yes. So I move over to my next term.
Okay.
So -2 times
Two.
-5 is 10. And 1 times 4 is 4. Were you guys writing down the matrices?
I did it on this one.
Okay, because I started right up again. I will give you a minute. Do you want to or no?
No.
Anybody want me to stop?
You're fine.
So, am I done with the first row with all the
Yes.
columns? If I had more columns, I would just what?
Keep going.
Keep going. Okay. So then I go to the second row. So -1 times,
One.
no,
No,
-1 times -1 is
1.
1.
Oh, I was giving you.
I know. 0 times 0 is
0.
0. -1 times -5.
5.
And 0 times 4 is
0.
0. So my answer for AB
2, 14.
is 2, 14, 1, 5. Did I get a 2x2?
Yes.
Yes. Now, I am going to tell you my advice when you do BA.
Okay.
And this is because I've consistently seen people not be able to do it, and I cannot consistently get the correct answer if I don't do this. Okay, sometimes, all the time, mathematicians, I always say we're efficiently lazy. We do what we have to do to get the right answer the first time so we don't have to do it again. Okay? Sometimes that means we do a few more steps the first time so we don't screw up things like negatives and like all those little tricks I share with you. It is very hard to do a row column backwards. 2x2s are okay. I can force my way through it, but it takes me twice as long to do. The easiest thing to do is just take this and guess what?
Put it over there.
Write it right here. This is going to take me 30 seconds to do, not a parenthesis, not even 30 seconds to do, and it's probably going to save me 5 minutes of the problem, especially if it's a big problem. Write them in the order you're multiplying them in. It will save you so much time. Your brain will not have to twist up as much. Okay, so then I might take -1 times -2 and get 2. And -5 times -1, 5. And -1 times 1, -1. -5 times 0, 0 times -2.
0.
0.
Am I going too fast? 4 times -1,
-4.
0 times 1,
0.
4 times 0.
0.
So I get what?
They're not equal to each other.
Well, yes, you get they're not equal.
7. -1. -4.
0.
0.
Okay, so the question was, are they equal?
No.
No. But again, you can't just answer no because could they possibly be equal?
Yeah. But
Yeah.
what if you know they're not?
No. They could possibly be equal. They could. I'm There are matrices out there that are inverses of each other, and we'll learn how to find those. And you get the same thing. Amazing.
No.
But some of them you don't have to work out, but in your assignment you do, because it says show that. If it says show that, we gotta work it out and prove it, don't we?
Yeah.
Unfortunately. But if you guys got this process down?
Yeah.
You get the process. So we'll just kind of discuss some of the. So I want to know if I take A times the quantity A plus B, if I get the same thing if I would get A times A plus A times B.
No, you.
Now you notice A is on the left of this quantity, yes?
Yeah.
So I'm distributing it in,
Yeah.
and it's staying on the left, isn't it? Okay, so should I get the same thing?
No.
Why?
I don't know.
Is matrix addition commutative?
No. Yeah.
Yeah. Matrix addition is commutative, yes.
But multiplication is.
But multiplication isn't. But what side is that A on?
The left.
The left. Did it
Actually-
stay on the left? Well, don't talk about the first one, it's squared. Okay, did the A stay on the left?
Yes.
Yes. In matrix operations, we have a left product and a right product. Guess where the right product is at?
It's on the right
It's
side.
on the right hand side.
Oh, really?
Okay, because
Oh,
they are
yes,
different,
that's
they're
right.
not commutative, so you have a left product and a right product. These should come out the same. Every time. Now, would you rather do the left or the right?
The left,
Why?
because it looks easier.
Looks easier?
Yeah.
Yes.
Don't you want to do the right first? Because, like, if you do the left first, you're gonna change.
Which one would be easier to accomplish? Because you are going to get the same answer. And in your homework, you're going to have to do both ways.
The right looks easier because it's already there. It's already.
Already
You don't have to.
it comes
The right, you think it's going to be easier, it's pre-distributed. Okay, on the right, how many times do I multiply?
Two.
Twice. Okay, is multiplication longer to do than addition? Does it take
No.
longer to do multiplication
Oh,
than
yes.
addition?
Yes.
Okay, so I gotta multiply twice, yes? What about the left?
Once.
I have to multiply
Three.
Once.
Four.
one time.
What?
I'm
you add the
adding
A
them
plus B.
first, and then I'm
Oh.
multiplying them. So which one is actually
The
shorter to do? The left. And you will see all the time when you have matrices and people are doing things with matrices, if they've got the same thing on the left or on the right, they factor it out and do the addition and then multiply one time. Because we're doing 2 by 2s here. That's not hard either way, is it?
Yes.
But think about if you had your 8 by 7 and 7 by 20. Okay. Do you want to try to limit the work you got to do?
Yeah.
First of all, you wouldn't do it by hand unless you were in a class. And
You would make us do it.
I would never give you that one. The biggest you're ever going to get by me is like a 3 by 4.
That's too big.
Okay, so do you guys want to work this out?
I got
Is
it.
that discussion good enough for that?
Yeah.
Okay. But remember, it's only working because that A is where? It's on
On the
that
left.
left-hand side. Okay. What if I had BB plus AB? How could I
No.
write that to make it easier?
You could do B plus A, or in parentheses, and then on that side is B.
Okay. So that my A plus B would be on the left-hand side. It's not moving, they're not moving positions, are they? That B is still on the right, isn't it? I'm just doing them in a different order. So again, as long as I don't move them, can I do them sometimes in different orders? Yes. Okay, so the next one is A times B times C equal to A times B times C.
No.
Did the matrices move orders?
Yes.
No.
No, they did not move at all, did they? All I did was I did the associative property, correct? And so since I didn't move orders, should they turn out the same?
Yes.
They should. Should we prove that to ourselves?
I believe you.
Well, you're gonna have to prove it on your homework.
I
not going
think
to.
it's true.
You think it's true?
Yep,
Okay.
Because if
I
you
don't
take
think it's
BC and you get that and you're multiplied by A,
Right.
you're still doing the same thing.
Why don't we do it real quick?
You're doing
We'll do
AB first before you do BC,
Right.
but you're gonna take A, you know what I'm saying?
Okay, so let's just do it real quick. Okay, let's take AB. Shouldn't take too long, right?
3 times negative.
3 times -2 is -6 plus 0.
And then
3 times 1, so 3 plus 0.
2,
Ooh, that's interesting. And then what?
negative
2.
2 plus negative 6.
So 2 minus 6.
No, 2 plus negative 6.
Okay, so I get
Negative 6.
-6,
3.
3.
Negative 4. 7.
Okay. So now I have to take this times.
6, 2, 4, 3.
Okay, so -12 plus 24. Okay, so I'm ending with -34.
24.
Oh, I just did the 2. Thank you. I just subtracted the 2. I know. And then 12, right? And then 4 and 48.
Yeah.
Okay, so when I do the other, it should work out the same, right? So we're gonna do BC. So -12. -4 plus 8. 18 minus 16. 6. I'm going to put it over here because I have to put A on the right, don't I? So I'm going to put A, so 3, 0, -1, -2. Times -8. 4. Oops, not -2. 2. And then
Negative
26.
6.
And then 12 plus 0. And 8 minus 4. And -4 plus 2, 52.
Yes.
And that gives me -24, 12, 4, and 48. Correct?
No.
Well,
I
that's
suppose.
supposed to be -2 that was bought.
It was, no, it's a positive. I started writing negative and it was positive.
No, it's supposed to be negative.
Looks like a
No,
UFO.
it's not.
Yeah, it is. You did.
UFO.
UFO.
Okay, there's one more example we're gonna do and that's it. But, so on your assignment, it's gonna say show that these happen. So to show that I have to do both of them, don't I?
Yeah.
But did you see how I just equaled them to the same thing so I didn't have to write it again?
Wow.
Okay. Ready to try one last one?
So is it equal?
This equals this. Those are long equal signs.
Oh. I got it.
Okay, so now it wants me to do IA and AI. Now you got, these are 3 by 3, so they're both 3 by 3, right?
So it's going to be
So I'm going to end with a 3 by 3. But what do you notice about I?
It's 1.
It's in
It's
reduced
one-
through it.
It is in reduced row echelon form. Good job, Kale.
Shut up, Kale. You're irrelevant.
Okay, it's a bunch of ones and zeros. Is a bunch of ones and zeros going to be really easy to multiply?
Yes.
Yeah, really easy. Okay, so we've got IA, right?
Yep.
Not okay.
Iowa
Not
and
It's going to be 1.
So I got
Indiana
1
and Iowa.
plus 0 plus 0. First row, first column, right?
Yeah. And it's gonna be
And then it's gonna be
negative
-3 plus
0
0
plus
plus
0.
0.
And it's gonna be.
We can't go too fast.
I
I'm
can't
just gonna go do the homework.
Okay, then it's gonna be what? 2 plus 0 plus 0.
Now it's gonna be.
Now-
0.
Second row. So everything's gonna zero out but the middle term, right?
I can't.
0 plus
Minus.
minus
4 plus 0.
And 0 plus 5.
Do you want me to just let you guys work on your own?
Yes.
Okay,
Please.
so Evan, you gotta be quiet.
That's what I'm doing anyway.
Here, Evan, you wanna write
Yeah,
it?
but Evan was
No,
like
I don't
messing
want
with
to
my
do
brain. Yeah, Evan, your monotone voice was not helping. Yeah.
It was helping me.
Okay, well.
Okay, I'll let you guys work. I'll give you about 30 seconds and then I will go. How about that? Tell me when you start your third row. That's on the third row yet.
I did it in my head, now I'm on the third row yet.
I'm not third row, but I've been ignoring your voice for a while, so.
I don't remember what I put though. My pencil in my mind is very
It's dull.
okay, the sharpener here.
There's over there now. You guys, shush. Did you, what happened?
I don't know, but it's
Wait,
Cinco.
wait, you just do zeros around, like it's
Wow,
literally
what did
it's the
happen?
same-
What
it's
happened?
the same thing. I figured that out.
Okay, it didn't change it, did it?
No.
What is a multiplicative identity? What is that? Anybody know?
They multiply.
You know what an identity is? Doesn't change it. So the multiplicative identity, what is the multiplicative identity of any number?
One.
1. So guess what that matrix is?
One.
It's basically the 1. That's why it's called I, because it's the identity matrix. That is a 3 by 3 identity matrix, and it's the multiplicative identity. So when I do IA, what should I also get? I should also get the same thing. Or AI, sorry. When I do that, I should do this. Well, let's do it. So I'm going to go this way, right? And I'm going to show you how hard that is. Try to go that way without rewriting.
What was
It's
that?
row by column, right?
Yep.
1 plus 0 plus 0 negative 3.
It's actually easier with this.
Yeah.
Okay. Am I going to get exactly the same thing?
You should.
Okay. So the identity, it is commutative, isn't it?
Yeah.
Okay. So this is a 3 by 3 identity. Anybody want to throw out a guess what a 2 by 2 identity looks like?
It's gonna be 1 0
1 0 0
1 0 0 1. What's a 4 by 4 identity matrix going to
1
be?
0 0 0 0
0 1 0 0.
I don't know, I know what it looks like in my head.
0 0 0 1.
On that main diagonal with that row echelon form, they're all going to be what?
zeros.
One.
You had 2 options,
Ones.
Evan.
And he got it wrong. They're all going to be 1s, and everything else is going to be what?
Twos.
Zeros.
Evan, helpful comments.
That is helpful.
2s. I choose. Zeros. You got it in my head. Okay, there is not an identity matrix for any matrix that is non-square. What's a square matrix?
Square matrix?
2 by 2.
Right, rows and columns are equal. There is no identity matrix for non-square matrices. There is none. So that is it. But when it says show that on those 2, you have to do it both ways. You can't just do it one.
What 2?
Got it? Okay. And on number 13, just multiply the two matrices. Do not worry about the 16,000 words they seemed that they needed.